Hello, and welcome back to our series exploring the Automated Drone Image Analysis Tool, or ADIAT. My name is Charlie Grove. I'm the Director of Technology for Texas Search and Rescue and the creator of ADIAT. In this video, we're going to take a look at the thermal image algorithms that we have in place in ADIAT. Now, these are new as of version 1.3, and we're very excited to add them to our collection of algorithms as it allows us to process thermal images for the first time. With that, let's take a look at the first one, which is the temperature range algorithm. Before we take a look at the actual algorithms in ADIAT, I did want to take a moment to talk a little bit about where that temperature data is stored in image files and how we access it. You may recall from our first video in this series, we talked about how the temperature information, thermal information is captured using the infrared spectrum, but what does it do with it at that point? How does it get stored in the image file? And to take a look at that, first let's start with a normal RGB image. So there's a lot of information that's actually stored in this file beyond just the pixel values here that you see. If we were to go into the folder, and let's go find that specific image. It's in our RGB section, input, and I believe it's our first one here. If you're on Windows, you can go into the properties, go over to details, and you can see there's a whole bunch of other information in here that can be useful to us. There's information about the image itself, information about the camera that was used to capture the image, some information about some of the exposure settings and whatnot that created the image, and location information. Since this was captured by a drone, we are able to save that information and know where it was captured and have the altitude, which is the altitude above sea level in meters. Now, if we want to move over to talking about thermal images, we can do that in a slightly more specialized tool that allows us to see more of that metadata that's embedded in the file. So for this thermal image, we see the information here, some of the same information we saw in the Windows properties about the file type, some of the settings for the camera, some information about the image itself. And if we go towards the bottom, we'll see there's a special section called DJI that includes an entry for thermal data. And a couple things to note here. One, the data is stored as a binary, which means it's not just plain text. And two, even once you unpack that binary, what's actually stored here is called radiometric data, which isn't just a temperature value, it's just the radiance value that the sensor collects. That information has to be used in combination with some of these other environmental variables to convert it to an actual temperature. So because of those two things, we can't just grab the data from here and say, oh, the temperature in this point of the image is 75 degrees Fahrenheit or what have you. There's a whole process that has to go on to convert it to usable values. And the way we do that, for at least DJI and Autel drones, is using specialized libraries that are available from the manufacturers called SDKs, or software development kits, and that's essentially the decoder library. So we call that library, we send it either the raw data or the entire file and say, hey, I have this thermal image with this radiometric data embedded. Can you give me back the temperature values for each pixel in the image? We will note this is the crux of why we can't support the thermal algorithms in Mac OS. DJI does not support Mac with their thermal SDK. Same for Autel. There are no SDKs available to support Mac at this point, unfortunately. So we are limited to only being able to support Windows for our thermal algorithms. The other caveat to touch on before we look at the algorithms is we talked again in the first video about there's the temperature data that's embedded in kind of that metadata section of the image, and then there's the visualization, and there isn't always as tight of a relationship between the two as you might hope or expect. And a perfect example of this is if we look at this particular thermal JPEG from DJI. This was a Matrix 30T, I believe, that captured this. We see that the image size is 1280 by 1024. If we take that same image and go into DJI's thermal analysis tool and open that image, we see that the image is 640 by 512. And the reason there's that discrepancy between these two is What we're seeing on the right is the visual interpretation of the data by DJI with some level of extrapolation, which got them to 1280 by 1024 pixels. The actual thermal data that's embedded in the image is only 640 pixels by 512. So just something to be aware of. It's not always a one-to-one relationship between the actual underlying thermal data and the original image. So something to be cautious of. I've seen it mainly in a couple of the DJI drones. So far, everything from Autel appears to line up pretty well, but just something to be aware of as you go through your analysis. Just because there's the awesome visualization that the drone manufacturer is able to generate for you doesn't always mean it aligns directly to the underlying temperature data. With that, let's go ahead and jump into ADIAT and look at how these algorithms work. Once we have ADIAT open, we can go ahead and select our input and output folders the same way we did for our RGB algorithms. We can go up to select, and this time instead of using RGB images, we're going to a thermal folder and selecting our input folder there. This is a good time to call out the list of cameras and drones that are supported for thermal imagery. The full list can be found on the ADIAT webpage at texar.org. But the short version is we support all the latest models from both DJI and Autel, as well as a few FLIR cameras. If you have a thermal drone that is not currently supported and you're interested in having it supported, by all means, feel free to reach out and we will do what we can to get it added to the list of supported drones. So I'll select my input folder, I'll select my output folder, and before I change my algorithm, note that these two features here, our two advanced features, are going to go away when I select one of these two thermal algorithms. We'll explain why in the next video when we talk about the advanced features, but they are not applicable to our thermal algorithms. So now I'm going to go ahead and select temperature range, and we see there are three parameters in the algorithm setup box here. We have the minimum temperature and maximum temperature, essentially creating a temperature range that we will be looking for. I have my preferences set for Fahrenheit. If you go into the menu and preferences, you can change that temperature unit to Celsius and use that for your analysis. We also have color maps here. So color maps or color palettes are that artificial visualization that is applied to thermal images to make them easier to analyze. It can either be showing areas that are hotter as black or areas that are hotter are white or some sort of colorization. Again, purely for visualization to make the analysis easier for humans. We support a number of them here. Each drone manufacturer, each computer vision library has their own names for these things. So you'll see in some instances we have two names for them. That's just to try to disambiguate a little bit so that you understand which one we're talking about. Let's go ahead and set this to hot or Fulbright just to make it a little more interesting. We'll leave our temperature range where it is and go ahead and hit start. And it will start processing our 55 files. As we make our way through this, we'll see that we are going through each one of these JPEGs. And just like we did, similar to the color range algorithm, what's going on, as we mentioned, we've got our minimum and maximum temperature here. We're looking for any pixels that are, or temperature values that are in that range. Same as always, if we find enough of those together, it's considered an area of interest, and we go ahead and flag that. So we went through our 54 images. There were 55 files in there. One of them was not an image file, so it got thrown out. Of those 54 images, there were 16 with areas of interest, and it took right around 24 seconds. So if we click on View Results, we will open up our viewer just like we do with our RGB images, and we will see the images that had areas of interest. You'll note on this first one, there's just this one giant circle basically around the entire image. During that analysis process, and I believe we talked about this on one of the earlier videos, areas of interest that happen to overlap once we put the buffer on them are combined, and that process repeats until there are no overlapping areas of interest. What happened here is so much of this image was probably in our specified temperature range that all those circles kept getting combined and combined and combined until we ended up with just one giant circle. So what that tells us is there's a large portion of this image that was in our specified temperature range. We'll see as we mouse around this in the bottom left corner there, temperature values. So for each pixel or cell in the temperature data table, we are providing that information to you, and you can go around and see specifically what the temperature is for any exact point in the image. Let's move on to an image that had some smaller areas of interest. Here's a good one. So in this one, again, if we mouse over, we can see specifically what in here was of interest to us. So these white hot areas appear to be what it was keying off of for these areas of interest. Just like with the RGB algorithms, we can click on the thumbnails in the right pane here, zoom on in, and we can go even more detailed, looking almost pixel by pixel at the temperature values. Now, keep going through these images. These are test images provided by the drone manufacturers, so it's kind of a mixed bag of what the images are of, just for reference. And we see these are mainly from DJI right now. Here's one coming in from an Autel drone, same exact treatment, works the exact same way. This one, it would appear, did have GPS information in it from Autel, so thank you, Autel, for including GPS coordinates in your test images. And you see in the bottom left there, now we have both the GPS coordinate information as well as the temperature information. If we want to move over to our second thermal algorithm, we have our temperature anomaly algorithm. And the way this one works is we're going to take all the temperature values in the image or in the underlying data set, and we're going to find the mean. And then we're going to say, hey, how many standard deviations away from that mean is any given pixel? We can specify if we want to only look for things above or below the mean. So for our purposes, let's say above the mean. And we want to go a little crazy. Let's go 6. And let's do jet rainbow. Why not? Different colorization. So we set our 3 parameters here. Which direction, what type of anomaly are we looking for? How many standard deviations away from the mean are we looking for? And our color map. We go ahead and hit start. And we start to analyze our 55 images, or our 54 images, 55 files, skipping that one. And by the way, that same process holds true for RGB image analysis as well. If there's something in the folder that is not an image, ADIAT will ignore it and move on to the next file. So you don't need to worry if you have a rogue text file or something in there. All right, we got our 16 images this time. And let's go ahead and look at the results. So we have an area of interest down here in this image. Let's go ahead and bring this up. Moving on to the next one, we circle some people in this one, and just the same way we would expect it to work, just like we did for temperature range, except we're just looking for areas that are anomalous, in this case above the specified mean, above the mean temperature of the image. With that, we can go ahead and close out this video. Those are the 2 thermal algorithms that have been implemented in version 1.3 of ADIAT. We will be looking to add additional algorithms as we continue to extend the functionality. Thank you very much.